So the story is that there's this pendulum bob that's going round and round in a horizontal circle. There are only two forces acting on the pendulum: its own weight vertically downward and the tension in the string. Since the pendulum bob is doing circular motion, we know that the direction of the acceleration is always centripetal, towards the center of the circle, which is here. So the direction of the acceleration is always towards the center of the circle there. But at this very instant, when the pendulum bob is at this position here, we know the centripetal direction is rightward, towards the center of the circle here. Since the direction of the acceleration is purely horizontal, we know the clever thing to do is to resolve everything into vertical and horizontal components, so that in the vertical direction, we know that the vertical forces should all balance each other out. Because the acceleration is purely horizontal, there's no vertical acceleration. As for the horizontal components, we can add them up and we can equate them to the mass of the pendulum bob multiplied by its acceleration. So this is what it looks like. In the vertical direction, the upward pull of tension is balanced by the downward pull of gravity. But of course, tension is not pulling vertically upward, so it's not going to be T equals to mg, but we need to take the vertical component, which works out to be T cosine 30 degrees. As for the horizontal forces, well, only tension is provide a horizontal component. So the horizontal component of tension, which is T sine 30 degrees, can be equated to its mass times its acceleration. But since this is circular motion, we know that the acceleration can be written as v squared over r. And the rest is mathematics. So we have two equations here. We are going to divide this equation by this equation. The tension will be cancelled out, the mass will be cancelled out, and all we are left with is tension 30 degrees is equals to v squared over rg. Now we just have to plug in all the right numbers. The radius here refers to the radius of the circle, which is this length here. For that, we are going to make use of the information that the length of the string is 42 cm. So that would mean that this length here, the radius of the circle, can be written as 42 cm times sine 30 degrees. So this is what goes in here. G is of course 9.81. Bring out your calculator, you will get V to be 1.09 meter per second. What we just calculated, V, is of course the tangential speed or the linear speed. To calculate the angular velocity, we will have to make use of the relationship V is equals to r omega. Again, r is the radius of the circle, which is 42 cm times sine 30 degrees. And you will get omega equals to 5.19 radian per second. Piece of cake. And thank you for using XM Physics.